recording now. So, okay, please don't scribble on there. You don't even know what we're
I'm just trading in what's trading.
I know, but you're going to see what we're going to be doing here is going to be, that's going to interfere with what we're doing.
Yes, Daniel.
So I have three. So when I multiply, really any numbers, you can think of the first number as how many of what you have of the second number, right? So if I have 3 times 2/3, that really means 3 of 2/3, right? And that's what I have right here. You can see I have 2/3 3 times. Now, before we just go on, how we want to show our work on something like this, can we kind of piece together what it is we actually have if we were to say, all right, what if I fill this in, let me get some gray, if I take one of the parts from here and put it here, and one of the parts from here and put it here, what is it I actually have, right? So, and let me get the marker nice and dark here.
Yeah.
So, okay. All right, now, so I'm going to just fill this gray in right here, right? And I'll take this one right here and I'll fill that in right there. And since I stole from that, you guys figure out how you're going to do this. You obviously don't have the advantage of this, and I can make this now white, right? Since I took that, and so these are empty now. And so, what is 3 of 2/3, right? What does it equal?
2.
It equals 2, right? You could also reverse this and say 2/3 of 3, and that makes a little more sense. 2/3 of 3 apples are 2 apples, right? So that gets 2 as well. Now, one thing you can do with a problem like this, you can also think about, making it into 2 fractions. And when you do that, you can say, well, like you guys, I've been hearing you say that catchy little jingle. Go ahead, how's it go? When you're multiplying fractions.
There's no problem. Top times the top and bottom times the bottom.
Right. Now, so when you multiply fractions, the algorithm is you multiply numerator by numerator and denominator by denominator. And because of that, it wouldn't matter what order you multiply them in. So technically, you could think of this as 3 over 3 times 2 over 1, and that's the same result. And since 3 over 3 equals 1, that's why we cancel in math, because it's really just kind of rearranging the numbers and realizing that 1 times 2 is 2. So you don't have to show all that. The way you want to, if you want to show this by canceling, you just, you don't want to go, you can obviously go 6 over 3 and get 2, but let's not do that. Let's cancel, because all canceling is doing is realizing I can rearrange this and have it be just one number over itself multiplied by whatever's left, right? And that's that business of canceling out your greatest common factor, and you end up, any way we've looked at this problem, we've come up with 2. All right? Now, let's look at this next one. So, I just always think it's helpful to get a visual of these kind of problems. If I say 1/2 of 3/4, right? That means, well, what have I given you here? 3/4. Now, what if I go ahead and make how would I cut 3/4 in half?
Oh, you would cut it in half?
I cut it in half, right? Well, I've got 3 parts, so I'm going to have to cut one of the parts into half, and that should divide it into 2 equal parts, right? Such that this is 1/2 of 3/4, right? And this is also 1/2 of, well, I'm cutting that, what I'm doing is cutting the 3/4 part into half, right? So what does each of these halves equal? That's the key here to understand. One thing I would tell you is that, so what we're interested to know is what does each one of these parts equal? What does this part right here actually equal? That's our answer right there, isn't it?
3/8.
3/8. Does everybody see how It multiplies, there's nothing we can cancel here. 1 times 3, 2 times 4 is 8, but there we see it, right? Half of 3/4 is, each of these equals 1/8, right?
Can I use a different colored marker?
Sure. So there's your 3/8. Half of 3/4 is 3/8. Okay? You guys take notes on that as it helps you, okay? You're leaving right in the middle of the notes. Okay? All right. Now, let's talk about this one. 1/3 of 3/8. Okay, so that means, so the way I'd like you to think of this one is, well, here is the 3/8, right? There's your 3/8, right? I want one of those 3 parts. What am I taking?
Multiply.
All right, well, I mean, what I'm asking you to do, Jack, is think about, that would be one of 3 parts of 3/8, right? Wouldn't it? How much is that? How much is that? 1/8. Does everybody see that that's 1/8?
Yeah.
I've taken 1 part of the 3 parts of 3/8. So that naturally has to be 1/8, not 3/8. That's what I started with, right? And I took one of those 3 parts. I've got 2 parts that I didn't take. But remember, what does 1/3 of 3/8 mean? It means
1/3.
take one of 3 parts of 3 parts of 8. And that makes it really easy when there's 3 parts of the total you're talking about. Now, by virtue of the commutative property of multiplication, you can always reverse these, right? So what is the commutative property of multiplication?
And this one is the same result.
What is that?
I was looking at the next,
Well, answer the question I'm asking. What is the commutative property of multiplication? Notice what I've done up here. What have I done? Yeah. And I can change the order of the numbers I'm multiplying and get the same result. So this time I'm asking you to think of, well, what about, now this was harder to think of it this way, but I want to show you get the same thing. So this is 1/3. So I want to do 3 parts of 8 of 1/3. So what did I do down here? I divided the 1/3 into how many parts? 8. And then I took 3 of those. That's what this is. You can see it kind of lightly shaded on the bottom version there. And you still get this same amount, right? Remember, this would be, like this part right here would be, right, 1/4, right, the purple?
yeah,
So that yellow part is equal to what?
180.
1/8, right? So this whole purple part is 1/4. So this is 3 parts of 8 of 1/3, right? So this equals 1/8, just like it did before, right? So we get the same thing whichever way we do it, right? And now, I'm showing the math on this. If I go 3/8 times 1/3, what would be the way to do this the smart way? Okay, Jordan? Well, no, I don't want you to do anything unnecessary here. What did I do in this last problem? What did I do not that one, on this one right here. What did I do here? I canceled, right? Because both the numerator and denominator have a common factor of 3, right? They did here also, right? So I want to cancel out the 3's and get 1/8. I don't need to take that step of calling that 3/24, do I? That's kind of an inefficient way to do it. Let's make sure if we see these common factors that we cancel them out. Question?
Yeah, if we can't cross out, or if we can't cross out, do we just multiply the top and the top
Yep.
and the
And that
bottom?
would mean there's no common factors in the numerator and denominator, so, okay? All right. Now, pull out one of the red sheets that I have, and it didn't quite, so what I had intended there, you can see I shaded it in when I printed it out. For some reason it didn't print out all red, but that red part is supposed to be all red, okay? Now, don't cross over there because those lines are very important. Those yellow lines are very important. So why do you think I did some color printing here? Why do you think I went to that trouble, Anna? The negatives, that's right. So this red part, forget about the yellow lines for a second. The red part is what? It's 1/4, but what? Why is it red? It's negative, right? So the red means negative. Okay? Now, why do you think I divided this into 5 parts? Well, I'm saying 3 parts of 5 of 1/4, right? Because really this says 3 parts of 5 of negative 1/4. Isn't that what it's saying? So if I was to take 3 parts of 5, where is 3 parts of 5? So I'm going to take these 3 parts. 1, 2, 3. And this is my answer. We have to figure out what that exactly equals. But when I divide force into 5 parts, what do I have? Now what does each of these little pieces equal? If I divide force into fifths, what does each little part equal?
1/20.
What equals 1/20th, right? So with that said, how much does this green part equal?
3.
What does it equal? 3 what? 3/20ths, right? But it's still red, nothing changed it.
So it's negative.
So the answer here is negative 3/20ths, right? Now let's see if this bears this out. Now this is exactly what you said. I'm going to put parentheses around there since that's negative. And I'm still going to multiply 3/5 times negative 1/4, right? Nothing cancels here, so I just go numerator, numerator, denominator, denominator, and I get what I'm supposed to of negative 3/20ths, right? Because I'm taking a fraction of a fraction, right? When I do that, I should get a smaller number, right? Yes, except the things are negative here. Yes, question.
So is it like in addition or like and stuff like where like for the absolute values, no matter what if there's a negative sign, it's going to be negative.
That's right. I mean, this is saying how much of the negative. It's like how much of the debt, right?
But say the negative was in the other number, would it that?
Right, that would change it, right? That would change. If you have 2 negatives, then everything would get negative, and those things would no longer be red.
If, say, you could cross cancel, and there was a negative 1 instead of a 5, and you cross cancel, would it still be negative?
Yes, you want to just count negative signs for your answers, because anytime you have, like, let's say you had a negative 5 there. If you had a negative 5 there, you can think of that as negative 1 times 5, so you can still cancel 5s out. All right, we'll see those little examples. So, those will crop up in the homework. Okay, so go to the other colored page here. So, what do you think the 8 red circles are here? Negative 8. Now, I need to say, I'm saying 1/4 of negative 8. What's that have to be? Okay, so it's saying divide it into 4 parts, right? So divide the negative 8 into 4 equal parts. That's what really this means, right? And I want to have one of those parts, right? I want to have one of those parts. It's not going to the top of it. So my answer is what? What's my answer here? Negative 2, right? My answer is negative 2. So how would the math bear that out? So if you go 1/4, now here we go. We're going to have that right here, Daniel. Negative 8 over 4. I'm sorry, over 1. So Daniel, I think this is a really good question. He said, can I still, what happens with the negative if I cancel? Well, you can really think, I don't need you to show this, but what you can really think of that negative 8 as is a negative 1 times 8. And then I can cancel here, right? I can cancel the 4,
That's
and
1.
cancel the 8, leaving a 2. And all I'm left with is 1 times negative 1 times 2 over 1, and that's still all equal to what it's supposed to be, negative 2. Right? Okay. All right, so let's go, so flip back to this page. It has 2/5 times 1 2/3. Okay, 2/5 times 1 2/3.
Oh, does it put into an improper fraction? Well,
Well, yeah, maybe. But let's just talk about it. So what have I shown here?
1 and
So
2.
this is 1 2/3, right? So make sure this is 1, and this is 1 2/3. So all that is equal to 1 2/3, right? Out of that, what am I taking? I'm taking 2 parts of 5. Well, the math works really nice on this problem. So when I turn 1 2/3 into an improper fraction, notice what that's doing here is taking that 1 and making it into 3 parts. And so what do I have here?
5/3.
I have 5/3 here, right? Now what's the problem here? The problem here is take 2 parts of 5, right? So how many? There's 1, 2, 3, 4, 5. I'm going to take 2 of those parts of 5. So how much is that if I take 2 parts of these 5?
That's 1.
Really?
No.
There's 2 parts of 5 if I do that, right? Didn't I just take 2 parts of 5? That's 1, 2. There's a third, fourth, and fifth, but I only want 2 parts. So what's the answer? What do you have here? It's not 2/5.
No, 2/3.
2/3, right? So the answer here is 2/3. So why am I showing you this? I'm showing you this. The math makes sense. So when I go 2/5 of 1 2/3, right? I do need to convert that to an improper fraction. Make that 5/3. Now we can cancel here, right? That common factor of 5. And what do I get? What I'm supposed to, which is 2/3. Right? Now, let's look at this one. Only one more diagram for you here. So which number did I show you? Did I show you 2 1/3 or did I show you 3 1/4? Okay, showed you 3 1/4. Okay, so let me move this down for a second. All right, so what does it mean to say 2 1/3 times all of this? Well, I've got a double, so let's just focus on the 2 here first. I'm going to double everything I have, right? And then I'm also going to add 1/3 of everything I have. Okay? So how much would that all be? Don't do the math yet. Don't do the math. So if I want to double all this, so you guys can draw that really quickly, I'm going to double all this. So what have I done so far? What have I done so far to 3 1/4? So I multiplied it by 2. Now I also have to add 1/3 of all this, right? Not 1/3 of my total here, but 1/3 of what I started with. So what would be 1/3 of, again, just focus on the top part here. What I also have to add is 1/3 of all this. So what's 1/3 of these 3? What's 1/3 of these? What's 1/3 of these 3? Okay, 1. So let me clone that and add it here.
We don't again?
And then I got to get 1/3 of this. So what's 1/3 of a 4th?
12, 2, 3.
So wait a minute now. I got to multiply. I got to put it in boom. So each of those, 1/3 of a 4th is a 12th. So I got to also add this much. That's also part of things. I'll make that gray. So whatever this total is, remember that's equal to 1/12. That should be my answer. We'll see if we got that, but that's what my answer should be. So what does all that equal? And then we'll do the work for it. So I've got 1, 2, 3, 4, 5, 6, 7 holes. Plus what else?
3/4.
Plus 1/2.
Oh no, it's a half in.
Plus what?
1 4,
One.
20, 12.
12. What's all that equal? What's 1/2 as denominator of 12? So that's plus 6/12 plus 1/12 equals 7 and 7/12. So let's see if we get 7 and 7/12. I think we did that right. Let's see if we get 7 and 7/12 when we actually do the problem. Because that's what we should get. So 2 1/3 times 3 1/4. You do have to put these in improper fractions, all right? So we're going to make 2 times 3 plus 1 is what?
7 thirds.
3 times 4 plus 1?
13, 4.
All right. Now, is there any canceling that can go on here?
No.
No. So 7 times 10 is 70 plus 7, so it's 91
91 over 12.
over 12. And I'm pretty sure that equals 7 and 7/12 it does, because 84/12 is 7. All right, you can leave your answer like that as well. See it equals what it's supposed to. Okay? All right. Now, a couple of
Wait,
these.
you missed one.
Did I miss one? Oh, yeah, sorry, let's get that problem down below. Thank you.
Oh, we don't have to do it.
Oh, put the circle over, okay. Let's move that over here. All right, 6 2/3 times 4 2/5. You guys do that one. I'll give you a 30-second head start. Let me pause this for a second. Okay. All right, so we did this problem. Is everybody in agreement that we should have gotten 88 thirds? We did 20 thirds times 22 fifths. Do good canceling here. Cancel factor 5 out. That makes a 1 there. So you get 4 times 22 over 3 times 1, 88 thirds. All right, 2 quick word problems, and we'll be done. So a recipe prepared chowder calls for 2 1/4 pounds of butter. If you prepare half of the recipe, how much butter do you need? So what is this?
4 times 1/2.
So 1/2 of 2 1/4, right?
Yeah.
So one way you can do this, you can say half of 2, use distributive property here, right? This is using the distributive property. Say half of 2, what's that? 1. Half of 1/4? 1/8. So that's your answer, 1 1/8. Don't forget units. 1 1/8 pounds of butter. All right, last problem in the notes is, so the 2002, the fee to park in a parking garage was $4. The fee 2 years before that was 3/4 of that fee. So this is really just what? 3/4 of 4. So again, 3/4 of 4. Hopefully everybody knows that that's 3. Includes your units, right? Okay. I think we can call ourselves finished here. So you've got about 7 minutes to start the assignment.